Hi, in this video, we are going to look at how we convert recurring decimals to fractions. Before we begin, I'd quickly like to look at terminating decimals. A terminating decimal is a decimal that comes to an end. This means it is reasonably easy to write down the whole decimal. So we can say 0,3 or 0,678. What about 1,27898 or even 9,28909? These are all terminating decimals. In previous grades, we have already learned how to convert terminating decimals to fractions. We should know that 0,2 is equal to 2 over 10, 0,52 is equal to 52 over 100, and that 0,001 is equal to 1 over 1000. Now, recurring decimals do not terminate. They carry on forever. These decimals follow a repeating pattern. Here we have 0,33333 and so on, where the single digit 3 is being repeated. In this case, we have 0,121212 and so on, where 1 and 2 are the repeated digits. What about 0,456456 and so on? Here, 4, 5, and 6 is our repeating pattern. Let's make some space. To show that a decimal is recurring, we place a dot or line above the repeating pattern. So with 0,333 and so on, we can say 0,3 with a dot above the 3. If we have more than one recurring digit, we can put a dot above each recurring digit or a line above all of the recurring digits. So in the case of 0,121212 and so on, we can either put a dot above the 1 and a dot above the 2, like this, or we can put a small line above the 1 and the 2. When working with decimals with a large number of recurring digits, it is always easier and quicker to use a line. So 0,456 recurring will look like this. Before we move on to converting recurring decimals, please remember that terminating decimals and recurring decimals are very, very different. So 0,3 recurring is not equal to 0,3. 0,12 recurring is not equal to 0,12, and 0,456 recurring is not equal to 0,456, as they have different values. When working with recurring decimals, you will see examples that are greater than 1, such as 3,523 recurring. You may also see decimals with non-recurring digits. Here we have 0,13 recurring, where 1 is our non-recurring digit. We may not be able to convert recurring decimals to fractions in the same way we have converted terminating decimals, but we can still convert them. To convert a recurring decimal to a fraction, we make the recurring decimal equal to x. Then we create two equations. For equation 1, we count the amount of decimal places to the end of the first set of recurring digits. Then we multiply x by 10 for each digit. For equation 2, we count the amount of decimal places for each non-recurring digit, and we multiply x for each of these digits. Finally, we can subtract equation 2 from equation 1 and solve for x. The aim here is to get rid of the recurring decimals so we can change leftover digits into a fraction. Let's convert the recurring decimals we have just looked at. Here we have 0,3 recurring. So let's start by making this equal to x. So I can say x is equal to 0,3 recurring for equation 1. And I'm going to write it again on this side of the page. 0,3 recurring. Now, for equation 1, we need to count the amount of digits to the end of the first repeated pattern. Here, 3 is our repeated digit, So we only have one digit. Multiply x by 10, and we get 10x. Then we multiply 0, 3 recurring by 10, and we get 3, 3 recurring. For our second equation, we need to count the amount of non-recurring digits. Here there are no non-recurring digits, so this is equation 2. To solve for x, we subtract x in equation 2 from x in equation 1. So our x value in equation 1 is 10x, and we subtract x in equation 2, which is simply x. Then we subtract the values. So from equation 1, we have 3, 3 recurring, and we're going to subtract the value of equation 2, which is 0, 3 recurring. Now in our equation, 10x minus x gives us 9x. On the right-hand side, we have got 3 recurring over here and 3 recurring over here. These values will cancel out, and we're left with our whole numbers. 3 minus 0 gives us 3. And now we can solve for x. So let's divide both sides by 9, and we say x is equal to 3 over 9. Remember to always leave your fraction in simplest form. 3 and 9 are both divisible by 3, and we see that x is equal to 1 over 3. This is the fractional format of our recurring decimal. Let's do another example. Convert 0, 1, 2 recurring into a rational fraction. So let's start by making our decimal equal to x. So I can say x is equal to 0, 1, 2 recurring, and we'll put it on this side as well. Now for equation 1, we need to count the amount of digits until the end of the first recurring pattern. So we have 1 and 2. We have 2 digits. So we need to multiply x by 10 twice. X multiplied by 10 is 10x. Multiplied by 10 gives us 100x. So we can say 100x. Now to multiply this value by 100, and we get 12, 1, 2 recurring. For equation 2, there are no non-recurring digits. So this is equation 2. Now let's subtract equation 2 from equation 1. So we can say 100x minus x from equation 2 is equal to the value of equation 1, 12, 1, 2 recurring, minus the value from equation 2, 0, 1, 2 recurring. On the left of the equation, 100x minus x gives us 99x is equal to, on the right hand side, the recurring decimals will cancel out, and we're left with 12 minus 0, which is simply 12. To get x by itself, let's divide both sides by 99, and we get x is equal to 12 over 99. Finally, let's simplify our fraction. Both 12 and 99 are divisible by 3, and we see that x will be equal to 4 over 33. Let's look at another example. Convert 0, 456 recurring into a rational fraction. Let's start by saying x is equal to 0, 456. And again, for equation 2 over here, x is equal to 0, 456 recurring. Now, for equation 1, we have got 1, 2, 3 digits in the recurring pattern. So we need to multiply x by 10 3 times. 10 by times 10 times 10 is 1,000. So we get 1,000x is equal to 0,456 recurring multiplied by 1,000 gives us 456, 456 recurring. In equation 2, once again, we do not have any non-recurring digits. So this is equation 2. Now let's subtract equation 2 from equation 1. So we say 1,000x from equation 1 minus this x value over here from equation 2. Make it equal to the value from equation 1, 456, 456 recurring, minus the value from equation 2, 0,456 recurring. On the left-hand side of the equation, 1,000x minus x gives us 999x. On the right, 456 recurring will cancel out. 456 minus 0 is 456. To get x by itself, let's divide both sides by 999, and we get x is equal to 456 over 999. Both 456 and 999 are divisible by 3. So let's simplify. And we see that x is equal to 152 over 333. Let's do an example with a decimal that is greater than 1. Convert 3,523 recurring into a rational fraction. Let's start by making our decimal equal to x. So we can say x is equal to 3,523 recurring over here, and x is equal to 3,523 recurring on this side. Now for equation 1, we multiply x by 10 for each digit in the repeated pattern. 1, 2, 3. So we're going to multiply x by 10 3 times, and we get 1,000x. Is equal to 3,523 multiplied by 1,000 gives us 3,523, 523 recurring. Now for equation 2, we multiply x by 10 for every non-recurring digit after the decimal place. And a lot of students look at this 3 over here and say, okay, I need to multiply by 10. But remember, we multiply by the amount of non-recurring digits after the decimal place. So in this case, we have no non-recurring digits, and this is still equation 2. So now let's subtract our x values. We have 1,000x minus x is equal to the value of equation 1, 3,523, 523 recurring, and we're going to subtract the value of equation 2, 3,523 recurring. On the left, 1,000x minus x gives us 999x. Earlier in this video, we said the reason why we multiply x by 10 numerous times is so that the recurring digits will cancel out. So in this case, 523 recurring will cancel over here and over here. But we do not cancel the whole number over here. because now we say 3,523 minus 3, which gives us 3,520. And now we can solve for x. So let's divide both sides by 999, and we get x is equal to 3,520 over 999. We cannot simplify this fraction any further, which means that this is now the fractional form of this recurring decimal up here. I want to do one more example with a non-recurring digit. Convert 0,13 recurring into a rational fraction. Let's start by making this value equal to x. So I can say x is equal to 0,13 recurring. And again over here, x is equal to 0,13 recurring. Now for equation 1, we multiply x by 10 for the amount of digits after the decimal place up until the end of the first repeated pattern. Now 3 is our repeated pattern, but from the decimal place we have 1, 2 digits until the end of the repeated pattern. So we multiply x by 10 twice. So we can say 100x is equal to 0,13 recurring multiplied by 100 gives us 13,3 recurring. For equation 2, we multiply x by 10 for every non-recurring digit. Here we have 1 non-recurring digit. So x multiplied by 10 gives us 10x is equal to 0,13 recurring multiplied by 10, and we could get 1,3 recurring. Now we have equation 1 and equation 2. So let's start by subtracting the x value of equation 2 from equation 1. And we say 100x minus 10x is equal to the value of equation 1, 13,3 recurring, minus the value of equation 2, 1,3 recurring. 100x minus 10x gives us 90x is equal to, on the right hand side, the recurring 3's will cancel out, and we're left with 13 minus 1, which gives us 12. To get x by itself, let's divide both sides by 90, and we get x is equal to 12 over 90. Finally, we can simplify. 12 and 90 are both divisible by 6. 12 divided by 6 is 2, and 90 divided by 6 is 15. This means that 2 over 15 is the fractional form of 0,13 recurring. We will look at more examples like these in our upcoming videos.